Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing classification based on molecular forces. In that I have told there are four types of these things classification based on molecular forces. First I told you elastomers, 5 are there. Elastomers first, second fibers, third thermoplastic, and fourth thermosetting polymers. There are actually this one by one I will tell you four only. Elastomers, first one, second one fibers, third one thermoplastic polymers, and fourth one thermosetting polymers. I will discuss one by one. First I will discuss, but here I want to tell about the this classification based on molecular forces. A large number of polymers applications in different fields depend on their unique mechanical properties like tensile strength, elasticity, toughness, etc. These mechanical properties are governed by intermolecular forces, that is van der Waals forces and hydrogen bonds present in the polymer. These forces also bind the polymers chains under this category. The polymers are classified into the four subgroups on the basis of magnitude of intermolecular forces present in them. Now I will discuss one by one. Elastomers is first one. Question is asked also, what is the elastomers? Correct? What is the characteristics? Then now I am going to discuss elastomers. Elastomers are rubber-like solids with elastic properties. In these this elastomeric polymers, the polymers chains are held together by the weakest intermolecular force. Weakest intermolecular forces. Here in elastomeric polymers, the polymers chains are held together by the weakest intermolecular forces. These weak binding forces permit the polymer to be stressed. A few cross links are introduced in between the chains, which helps the polymers to retract to its original position after the force is released, as in vulcanized rubber. In vulcanized rubber also happens same things. Examples are Buna S, Buna N, neoprene, etc. Buna S. Last class I have told about the Buna S. S means here styrene. Okay, and that is the these things. Buna, that is the 1,3-butadiene plus styrene. Then Buna S is formed, and other is Buna N. Here N means nitrogen. Cn will be actually attached. Cn will be attached with the these things 1,3-butadiene. Cn, N is there. Now next I told you neoprene. These are the examples of elastomeric polymers. Again I am telling you example: Buna S, Buna N, neoprene, etc. Next is, but here neoprene, I want to tell you a structure. Then here you can understand neoprene structure very easily. Here 4 carbon chain will be there, chain of 4 carbon, and between carbon 2 and 3 double bond is there, and between carbon and 2 double bond, and only with carbon 2 Cl will be attached, and this will repeat many times, it will repeat. That's why you can represent it CH2, CH2C. First carbon is CH2, CH2 is there, second C, third is CH, then second and third double bond is there, and only with this C, Cl is attached, and with third one more CH2 is attached, means CH2 C, C double bond CH, again single bond CH2, and with carbon number 2 Cl is attached, then whole will be N, many times it will repeat, means this you can write in bracket CH2C double bond CH, CH2, whole things you can write in bracket, and with the C, Cl is there, don't forget. Then CH2 CCl, C with C, Cl is there, and then C, CH, CCH double bond is there, again CH2. Then this whole things are under bracket N. This unit will be repeated several times. That's why N is written. N may be any number of unit. This is called neoprene. Neoprene, very very important. This unit I told you. In polymerization, neoprene is very very important. Now next is fibers. What is fibers? Fibers are the thread forming solids which possesses high tensile strength and high modulus. These characteristics can be attributed to the strong intermolecular forces. Correct? This high tensile strength and high modulus, these two properties are attached with fibers. Then fibers are thread forming solids. It is just like a thread forming solids which possesses high tensile strength and high modulus. These characteristics can be attributed to the strong intermolecular forces like hydrogen bonding. These strong forces also lead to the close packing of chains and thus impart crystalline nature. Okay, here these strong force means intermolecular forces. I told you like hydrogen bonding. Okay, these strong forces also lead to the close packing of chains and thus impart crystalline nature. The examples of polyamides means nylon 6,6. Nylon 6,6 is polyamide. Polyester, you might have heard the name cloth, polyester. Polyesters, okay, that is called, directly you can tell polyesters, also called terylene. Correct? Cloth, you have seen cloth, terylene cloth, that is actually polyesters. Then these are the examples of fibers. Okay, means fibers examples I told you, that is the polyamides, and polyamides examples are nylon 6,6. Second example, polyesters, also called terylene, etc. And already I told nylon structure, nylon 6,6, that is the Here you know that two NH2 are there. Then again I am telling you one more time, that is the NH. It will start with NH, and this N is attached with CH2 whole 6. 6 times CH2 will be there. That's why this NH, that N is joined with CH2 whole 6, and this CH2 whole 6, that will join with again NH, correct, and this N will join with CO. C and O double bond is there, and again this C has joined with CH2 whole 4, CH2 whole 4, and finally this CH2 whole 4, that will join with CO, C double O. You know that it became long because that is one is this thing, carboxylic acid, C double O, CH2 whole 4, C double OH both sides, CH2 whole 4 in the middle, one side C double OH, other side also C double OH. This has actually joined with hexamethylene, diamine hexamethylene. Okay, hence it became long. Then this will repeat many times. That's why this unit you can write outside N, correct? Means NHCH2 whole 6, NHCO, again CH2 whole 4, CO. This will any time it will repeat. Hence you can write in bracket, and outside N you can write. This is the example of nylon. Now this next is thermoplastic polymers. Thermoplastic polymers. These are the linear or slightly branched long chain molecules. Thermoplastic polymers, it is new for you people, listen carefully. Thermoplastic polymers are the linear or slightly branched long chain molecules capable of repeatedly softening on heating and hardening on cooling. This is the characteristics of thermoplastic. Okay, repeatedly softening. It is actually these small chain long. It is a long chain molecules, linear or slightly branched long chain molecules capable of repeatedly softening on heating and hardening on cooling. These polymers possesses intermolecular forces of attraction intermediate between elastomers and fibers. Here you have to understand very clearly, these polymers possesses intermolecular forces. Here also intermolecular forces are there, correct? These polymers possesses intermolecular forces of attraction, but how much? Then intermediate between elastomers and fibers, because in both intermolecular forces are there, but here that this intermolecular force of attraction will be intermediate between elastomers and fibers. Some common thermoplastics are polythene, polystyrene, polyvinyl. Okay, polyvinyl, PVC, polyvinyl, you can tell, polyvinyls. Then these three examples are common: polythene, polystyrene, polyvinyls. Now next, but here PVC, already I told you, again I am telling you, how will you represent the PVC? Polystyrene, that is the styrene repetition. But here polyvinyl means CH2CH. With this CH, Cl is attached. Then this will be repeated. This is the repeating unit. CH2CHCl. Then both carbon, one valence is opened with both carbon for joining purpose. Then CH2CH with this CHCl is attached. This you can write inside the bracket, and outside down you can write a small n. This is actually PVC. Next is thermosetting. Thermosetting polymers. Now I told you thermoplastic. Thermo means heat. You remember thermoplastic, and its characteristic I told you that on heating it will become soft, and on cooling it will become hard. But here in thermosetting polymers, now see the characteristics. These polymers are cross-linked or heavily branched molecules which on heating undergo extensive cross-linking in molds, MOULDS, molds, and again become infusible. Okay. Again I am telling you, these polymers are cross-linked or heavily branched molecules which on heating undergo extensive cross-linking in molds and again become infusible. These cannot be reused, only one time use. This can't be reused. Some common examples are bakelite. Second example is urea formaldehyde resin. Urea formaldehyde is actually resin. Okay. Then second example is urea formaldehyde resins. Then bakelite formula I am telling you, chemical formula. Here actually two benzene rings are attached. Two benzene rings are, but both benzene rings are attached through CH. To many actually benzene, one molecule is benzene, phenol actually you can tell. Phenol is attached via CH2. Correct? Phenol is attached via CH2. Again, this CH2 can again further attach with another phenol. Correct? Again, that third one can attach with fourth one can attach fifth one, phenol. Okay? Then repeating unit is phenol. Two phenols are there. Both phenols are attached through CH2. Okay? And in second ring, again CH2 is there for further linking. Then this you can write these two benzene ring joined with CH2, and in second again CH2 is there, and one both side, first benzene and in second benzene CH2 is attached. That carbon also has one valency for the further linkage. Then this is the unit for repetition. This unit will be repeated. That's why this you write inside the bracket, and down you can write a small n. This is called bakelite. This is the formula for bakelite. Next things I am going to discuss. Next classification based on growth polymerization. Classification based on growth polymerization. Many classification is there. Then here that is a simple, already I have discussed addition and condensation. The addition and condensation polymers are nowadays also called chain growth polymers. Correct? Addition and condensation, last class I discussed, that is actually also called chain growth polymers and step growth polymers. Only addition and condensation. Addition is called chain growth polymers and condensation is called step growth polymers, depending on the type of polymerization. The addition and condensation polymers are nowadays also referred as chain growth polymers and step growth polymers depending on the type of polymerization mechanism they undergo during their formation. Now I am telling you type of polymerization reaction. Polymerization reaction. We are giving importance here on a reaction. Okay. Then on the basis of reaction also we can tell that is the types of polymerization reaction. How many types are there for polymerization reaction, that I am telling you. Then here first I am telling you addition polymerization or chain growth polymerization. Already I told you that in addition polymerization unit will attach. All unit will attach to itself and nothing will come out. No elimination. Nothing will Cl, H2O, sometimes alcohol comes out, but here nothing. Simply addition. Then what are the actually mechanism in this reaction I am telling you, because in long question this is asked. Okay, mechanism, that is called free radical mechanism. Free radical mechanism. Then here you should understand details in full question, long question. This is asked in written examination, subjective. That time this question is asked, and from concept point of view also it is important. Okay, here I am briefing you actually free radical mechanism. There are some steps. First step, that is the chain initiation step. Okay, first is chain initiation step. Second is chain propagation step. Third step is chain termination step. Okay, then here 3 steps I told you, and that now I will discuss in details. Okay, 3 steps are there, important step. Chain initiation steps first. Second, chain propagating step. Third, chain terminating step. Then now I will tell little details of free radical mechanism. Here just to understand, free radical mechanism means just by simple example I am telling you. Suppose ethane is there, CH3, C2H6, you can write like CH3, both CH3s are joined with single bond. Then now this single bond, when it will break, then both will take one electron. First carbon will take 1 electron, second carbon will take 1 electron. Then this is called actually free radical. 2 radical you will get methyl radical, then both are called free radical. Then now that reaction will take place through this radical. Then first step will be just one catalyst you will use in this reaction. Correct? One catalyst is actually used, that will give you, that is one free radical it will give. By use of catalyst, suitable catalyst, you will get free radical. Now this free radical, because itself is free radical, when it will react with other you can say molecules, then what it will do, their single bond will break. Then again 2 more free radical you will get. Correct? Then now this radical from catalyst and one radical from molecule, both will join. Now one radical is free radical is remaining, that again will same thing it will do with the next molecules. Suppose you have taken ethylene, only you have taken ethane you have taken C2 is CH3. Then suppose many molecules are there, CH3. Then now what happened with one molecule? One radical was remaining. Then now again what will happen, that it formed a radical from catalyst that joined with the one part of the new molecule, correct? Then now that has made the bond, single bond, correct? Then now you can say that one radical created one more radical. One radical, when it reacted with the molecule, it created another radical, correct? Then like that way, that radical will create another radical, that you remember. Now I am going to little details. Okay, a variety of alkenes or dienes and their derivatives are polymerized in the presence of free radical generating initiator, that is the catalyst, like benzoyl peroxide, acyl peroxide, tertiary butyl peroxide. These are the catalysts that will generate initiator, correct? Free radical generating initiator. This is actually catalyst. Example of this free radical generating initiator is benzoyl peroxide. You know that peroxide will break, then it will create free radical. Then example is benzoyl peroxide. Second is acetyl peroxide. Third is tertiary butyl peroxide. Okay, now just for example I am telling you how does it create. I am telling you, for example, the polymerization of ethene. Ethene means double bond. Okay, ethene, now I am talking about polyethylene. How will you make? That I am telling about. Ethene, for that ethene is required double bond. Then for example, the polymerization of ethene to polyethylene consists of heating or exposing to light a mixture of ethene with a small amount of benzoyl peroxide initiator. Listen here you require ethene and you have to heat it, or you can expose to light. Then what will happen? A mixture of ethene with a small amount of benzoyl peroxide initiator. What will happen? The process starts with addition of phenyl free radical. Benzoyl peroxide will produce phenyl free radical. Okay. The process starts with the addition of phenyl free radical formed by the peroxide to the ethene double bond, thus generating a new and a larger free radical. This step is called chain initiating step. Correct? Benzoyl peroxide phenyl free radical it form that will attack to the ethene, that will join with the ethene. Then in ethene double bond is there. Then one bond will break. Correct? Then one electron will be taken by the one carbon, other electron will be taken by the other carbon. Correct? Now double bond becomes single bond. Then these radical, now what ethene got one electron, both carbon got one electron, because one bond broken, only one bond is remaining. Then this is also, you can say, just like a free radical. Then these CH2, I am talking about ethene, this CH2 that has one carbon, that will join with peroxide, correct? Now this step is actually initiating a step, correct? As the radical react with another molecules of ethene, another bigger sized radical is formed. The repeating of this sequence with the new and bigger radicals carries the reaction forward, and the step is termed as chain propagation state. When more and more ethene will join, ethene will join, because one ethene, when one bond broken, then each carbon has taken one electron, correct? Now another ethene will come, then also same situation will happen. One bond will break and both carbon will get one electron. Then this carbon which has one electron will join with the first ethene which has one electron. Then they will join. Now second one has joined with first ethene by single bond. Like that way, now next ethene will come fourth, then again that bond will break. Then both carbon will take one electron. Then that carbon will join with you can say third ethene. Third ethene has one bond broken, correct? Then that third will join with the second. Then now again third one carbon has one electron. Then again a next ethene will come, then that will also bond will break. Then again both will get one electron. Then again they can join with third one. Like that way it will continue, long chain will be formed. That's why this step is called propagation step. And first step is the initiation, second step is the propagation. Then how many times it will go? It can make very long. Then somewhere it has to stop this propagation. Then now third step will be, after the chain propagation, third step will be chain termination step. Chain termination step. Okay. Then actually this catalyst role is only to break the bond. Ethene double bond is there. That bond, in presence of that, it will break. That is its role, and it will create a radical, free radical. Okay, and then again next ethene, but all ethene will join to each other. Then now reaction, I am telling you that chain termination step, benzoyl peroxide is there. Then benzoyl peroxide formula is C6H5 CO, C and O double bond. Then this CO, now this benzoyl, two benzoyl group is there. Then both are joined by oxygen, C6H5CO, and in the middle peroxide will be there, OO. Both are actually, you know that in peroxide H2O2. Now suppose both H is not there, then only O is there. Then O and O single bond is there, and both O has one electron, free electron, or you can tell one valency is there to make bond with others. Then O single bond, and each O has one electron, or you can tell one valency, each oxygen. Then that actually oxygen is joined with C6H5CO, C6H5CO, that carbon, from that carbon O has joined, correct? And this second oxygen also joined with another C6H5CO, correct? Means in the middle OO is there, and both side C6H5CO is there, both side. Okay, C6H5CO is joined with one oxygen, and other side again another C6H5CO is joined with another oxygen. This is called actually benzoyl peroxide. Then here that OO single bond is there in the initiation step, that bond will break and it will form two molecules of C6H5CO, again one O, C6H5C double bond O was there, and with that carbon one O is also there, correct? Means C6H5C double O, you can tell C6H5C double O, but that one is a double bond, other is a single bond, but that oxygen has one electron, it is in a radical form. Then two radical it will form, correct? 2,6H5C double O double bond and one oxygen single bond, that oxygen has one electron, means this is a radical. Then two radicals are there, same two radicals. Then after that what will happen next, that this C double O is there, C double bond O and one O, that will go as a CO2, because this reaction takes here in the presence of heat or light. Then this C double O will go, that is C6H5 which was joined with CO, that bond will break. Then you will get two phenyl radical. And CO2 will go, and C double O will go as a CO2. Then how actually it will go, that also you can understand. When C6H5 that is joined with CO, that bond will break, then both will take one electron. Carbon has one electron and oxygen was having one electron. Then now both electron can make one bond. Then it will go as a CO2, and now C6H5 that will take one electron because bond broken. Then two molecules of C6H5, two free radical you got of C6H5, that is called phenyl radical. Then now any one phenyl radical, two phenyl radicals are there, that will react with ethene. Then ethene double bond will convert to single bond, and C will join with phenyl free radical, correct? Then now phenyl radical joined with CH2, then another CH2, they will have one electron. That is that, then this molecule itself is called C6H5 CH2. Then last CH2 has one electron. Then this molecule is called actually a free radical. Then now next chain propagation step. Then now this actually C6H5 CH2 radical, it will attack to the next ethene. Then that bond will break, double bond becomes single bond. Then again it will join with the next ethene, correct? Then now second ethene, second carbon again will have one electron. Now again it will chain become long. Then last carbon has one electron, means now it is become free radical, long free radical. Then that will again join with the next ethene. Then again further it will long, and a new ethene which joined that carbon, that second carbon again will be, again it will have one electron, means always last carbon will have one electron. Then it will continue for many long. Then this step is called chain propagation step, correct? Then now third step is chain terminating step, because you have to stop this chain. Then for that purpose, what will you do? Then now what will happen here? For termination of the long chain, these free radicals can combine in different ways to form polythene. Okay. One mode, I am telling you, one mode of termination of chain. Here what will happen? Suppose now this what you got during propagation, free radical you got, then two free radical now suppose are coming together. Two free radicals suppose now coming together. Then both last carbon has one electron. Both two chain suppose came. Both chain last carbon has one electron. Means they both are free radical. Then both free radical again can join and can make a bond, both chain. Then you can it will be very long, and you can write in a very easy way. That is a first end C6H5 was there. Now second chain also joined, that was also having C6H5. Then both end C6H5 is there, and in the middle CH2, many CH2 will be there. Hence you can write CH2 in bracket outside, down you write N, a small n. Then here you can see how much you got long chain. Now you can understand. Correct? C6H5 is outside, inside the bracket CH2 many times and you can write after that again this first chain joined with the second chain, that also was having same way CH2 many times. Correct? And in the end it was joined with C6H5. Then for the CH2 it is the repeating unit. Hence for all CH2 you write N, in the bracket you write CH2 and outside a small n you can write. Correct? Then this is actually what you have written inside CH2 then both side C6H5 is there. Then suppose this bond breaks, then the both end will be free for further joining. Correct? Then this is actually chain terminating step, and this is called polythene. If C6H5 will not break, then it will be like that only, no problem. You can write both end C6H5 also. Okay. Then now I am stopping only here. Next class again I will discuss this thing, preparation of some important addition polymers. Correct? Like low density polythene, high density polythene, and other addition polymers are there, that I will discuss next class. Thank you.